All right, how you doing? In the class, some students in the class asked me to explain the do now and explain today's lesson on 1031 to 2020. All right, so we're going to jump into it. The diagram below shows the construction of a perpendicular bisector of AB. Okay, so the first question you have to ask yourself, what does a perpendicular bisector, what does it do? So it does two things. It split the line segments into two equal parts and it formed 90-degree angles. And this question states, which statement it's not true. Be careful of the not questions, because we're looking at the questions that's true. Going to be one of them that's false. So number one says AC is equal to BC. So AC. Okay, now we're going to look at, use a different color. Is equal to CB. That's true. Because it's got this half is equal to that half. That's true. Let me erase this. Now get myself situated. Now it says CB. Okay, so we got CB. And it's a half of AB. So you have AB here, and what they're saying is, you see the half in front? They say a half of AB, meaning you could scratch, I'll use white here. That means if it's half of this, if it's half of the whole thing, that means you take away one half of it, which will leave you a half. So that's equal to each other. So that is true. And if you didn't understand that concept, let me know and I'll try explain it a little further. So if they give you a full line, it's a half of that full line. So 2 is true. Now, AC, so they give you half a line AC, and it says equal to 2 times AB. What does that mean? So you have AB, and you see that number 2 multiplying, so they're saying that you have one line times another line, which is double the size. So what this statement is saying, number 3, they're saying that 2 lines equal to half the original line. So that's the only one that I see is false. But I'm going to look at, a lot of people had trouble with number 4. So I'm going to try to explain that. This class, like I said in the class, it's pretty much, a lot of it is abstract. And you think logically. So here it says AC. So you have AC, that's that right there. Plus, use orange, CB, which is that half there. And it says that's equal to AB. That is true. Now think about it logically. If you have this half of a line plus this other half, if you put them together, will give you this full line. So that is true. So the only answer that's false that I see is number 3. If you have any questions, you could write on my YouTube chat, or you could talk to me in class, like some of you are doing, which is fine. Oh, I don't have to erase it. All right, let's scroll down to the bottom. Now, we talked all about this earlier. So some classes I got through the formative assessment, but some classes I didn't. So I'm just going to go over it together. So it says in the formative assessment, in triangle AED with ABCD shown in the diagram below, EB and EC are drawn. State a valid conclusion if EB is an altitude of triangle AED. So with this class, you gotta go by the definitions. So they only ask about altitude. So EB, so the altitude do one thing. It tells you the height and it form 90-degree angles. Okay, so what does it say here? It says state a valid conclusion. EB is an altitude of triangle AED, which is AED. Okay, so let's translate this. What you learn. So if they're saying it's an altitude, so we gotta go what we know. So we know EB is perpendicular to EB is perpendicular to AB. That could be an answer choice. EB is perpendicular to BC. That could be an answer choice. EB can be perpendicular to AD. That could also be an answer choice because it forms that 90-degree angle. Because remember the definition of altitude, it forms 90-degree angles. Or if you want to go with the angle standpoint, you could say angle EBA is equal to angle EBC. That could be another answer choice. Any one of those, they're fine, but eventually we're going to start doing proofs, and you got to go what you know. Like I said, the tricky part is when you look at the picture, you will go by the picture, so you got to be careful of that. All right, so let's look at the next question. Let me scroll up. Okay, let me still have that picture. I'm going to erase what's up there so we could see what's going on here. All right, so it says, state the valid conclusion if EC is the medium of triangle BED. All right, so let's scroll up a little bit. I'm going to zoom out a little bit so we can see the whole thing. So this says state a valid conclusion EC is the median of triangle BED. So let's highlight a couple of things. So they said EC. So EC is a median. Okay. Of triangle. Use orange again. BED. So what do medians do? If you remember, it starts from the vertex and it goes through to the segment, and it breaks the segment into two equal parts. So what the median does, I know BC is going to be equal to CD because that's the definition of a median. Because remember, start from the vertex, you go down and break up the line segments. So the answer that we're looking for, it's going to be line segment BC is equal to CD. That's the definition of the median. Okay. That's all I see there. I'm going to ask Mr. Chan if you see anything else, but that's the information that's given. That's what I see. Now let's go to the extra credit, because some of you do the extra credit, and let's jump into it. As shown in the diagram below, CD is the median. Okay, so CD is the median of ABC, ABC, okay? Which statement is always true? So again, what's the definition of that median? So let's look at that orange, because it starts from that vertex C to D. So we know that D is that midpoint. So now, since I know, because it starts from the end and it goes to that midpoint right there, so I know AD and DB is equal, which is, that will always be true because that's the definition of the median. Because you start from the vertex and you go down and break up the line segments into two equal parts. So AD is equal to congruent to DB. Okay. All right, now let's look at the other answer choices. Let's use a different color here. I'm gonna clear this. Okay, so all right, so this is always true. Now let's say is AC. Let's use a different color here. Let's go with this blue color. So it's AC. Is that equal congruent to AD? Based on this information, I do not know, because like I'm going by a definition of the median, so I do not know if AC will always be equal to AD based on the information that's given. So that's out. Let me erase that. Oh, sounds like one of my kids are up. Okay. Now it says angle ACD. ACD. So I'm going to use blue. So they're saying, what is it? ACD. So this angle right here is equal, congruent to ACD. Hold on. I'm sorry. It says BCE. Let me do that again. My eyes are playing tricks on me. All right, ACD. So ACD. Okay, I was right the first time. So they're saying that ACD is equal to CD. It's right here. B. I don't know. Based on the definition of a median, they don't talk about that in that definition. Remember, when you median break up into two line segments, so that's out. Now let's talk about, we use green. EC, let me erase this. ECD, BCD. So BCD, so this angle here. Oh. I'll try again. BCD, this angle right here, is equal to ACD. ACD, oh, that looks so tempting. But again, based on this definition, it doesn't tell you about the vertex and angles, it only tell you about the line segments. So that answer is out. So the answer, I know that will always be true, because according to the definition of a median, it breaks the segment of AD, because you know D is the midpoint, starts from a vertex. I know those were broken up into two equal parts based on the definition of the median. Okay, so hope that helps. If that didn't help, let me know. And it's late. I promise a couple of students that I will get this done by today. And just let me know. I know it's the weekend, so enjoy your weekend.